Okay guys, so what I've done here is I've constructed an angle. Remember, an angle is made up of two sides. The initial side, which we fix on the x-axis if it's in standard position, and then we have the terminal side, which kind of moves about the initial side. And then I have a blue line here that we call the arc length. The arc length is the path that this point has traveled from our initial side to our terminal side. So you'll see that the arc length is increasing as my arc length increases as my theta increases, right? As the angle between the initial side and the terminal side increase, so does the distance traveled by this dot from the starting point, which was this dot D, right? Okay, so what happens if I let this theta keep increasing? What's going to happen to our arc length? And what's the pattern that's going to start tracing out? Well, as we can see, because our terminal side stays fixed, as it rotates about my initial side, it starts creating what shape? Yeah, you guessed it. It's a circle, right? So we can see if we keep the initial side and the terminal side fixed, what's going to happen is that it starts tracing out a circle. So it's going to look kind of like this. So now what I wanted to do in this video was I really want to show you the connection between theta, our angle measure, and what we spoke about in earlier videos, which was our trig functions. Do you guys remember our trig functions? We had things like sine theta, which was opposite over hypotenuse. Then we had cosine theta, which was a ratio between the adjacent side of a right triangle and its hypotenuse. And then we had tan theta, which was what we called opposite or over adjacent. So how does this rotating angle around this circle deal with right triangles? Well, what we can do is this. Let's see if I can get this angle fixed where I want it. Let's see if I can get him fixed all the way at 45 degrees. Sometimes he's a little finicky, so let's see. Come on. Fix. All right, well, he's close enough, all right? He's about 45 degrees. So what we're looking at right here is we have a radius of length 3.15 and we have an angle of about 45 degrees. I'm sorry I couldn't make it perfect. And what I can do here is I can extend a line from this point where my terminal side hits the circle, and I can extend it down to my x-axis, right? So I can extend it down, and then I can make another line from this point all the way back to the origin. So it looks like this. So what have I constructed here? Well, I've constructed a right triangle. So this angle right here is 90 degrees because it's going from straight up and down to straight left and right. It goes from vertical to horizontal, so I know this is a right angle. So right now I have a right triangle with, let's just assume that this has 45 degrees. When I did the practice run, I was able to get on 45 degrees exactly, but it's not working this time. So remember, sine, when we talked about trig functions, sine of an angle is equal to opposite over hypotenuse. So right now we're given sine of 45 degrees. So sine of 45 degrees should equal 0.71. So if you're at home and you have a calculator on you, what I want you to do is this. We're going to take sine of this angle, which is 45 degrees, and it should give us, this is a rounded answer, it should give us about 0.71. And then what I want you to do is this. I want you to take, let's go back to sine. It says opposite over hypotenuse. The opposite side is this side. I want you to take the length of this side, which is 2.23, and divide it by the length of the hypotenuse, or the longest side of this triangle, which happens to be the radius. So take 2.23 and divide it by 3.15 and tell me what you get. You should get approximately 0.71. So this is the connection between a circle, its radius, the angle, and our trig functions. This is where it all comes from. The other important thing is this. Look, right now our radius is 3.15. What if I make our radius, I don't know, let's blow it up a little bit, okay? If I can zoom out, and I'm going to extend him. I'm going to extend him this way. Boom. All right, so now my radius here is 4. My adjacent side to this angle is 2.83, and the opposite side is 2.83 as well. The only thing I didn't change is this angle measure. The angle measure is still rounding 45 degrees, right? So I want you again to do a calculation. Take the opposite side, which is 2.83, and divide it by the hypotenuse, which is 4 here, and tell me what you get. You should get about 0.71. So what does this tell us? Well, the cool thing about trig functions is that it doesn't matter the size of the triangle, right? It can be a triangle with side 2.83 and hypotenuse 4, or it could be a tiny triangle, right? And guess what? These ratios will still hold still, right? So if you take 0.46 and divide it by 0.65, you should still get 0.71. This is the beauty of the trig functions.